Hello everybody, this is Mrs. Snook with section 4.3 and we're going to do this over 2 days. So this is day 1 of 4.3. Now this section is about right triangle trigonometry, and in many ways it should be a review of what you've done before. So as a reminder, right triangle trig involves using SOHCAHTOA. S for sine, O over H is opposite over hypotenuse. Cosine is adjacent over hypotenuse, that's the CA, and TOA is opposite over adjacent. And today we are going to evaluate trigonometric functions of acute angles, and we're going to use a calculator to evaluate trig functions. So first off, let's take a look at this right triangle. We have a 90-degree angle, so we know it's a right triangle. And then our angle over here is x. The adjacent side is the side that touches the 90-degree and the angle. The opposite side is on the other side of the triangle from the angle. And then the hypotenuse is the one opposite the 90 degrees. And it's going to be really helpful as you do these problems to label your sides, opposite, adjacent, and hypotenuse. So review, sine is opposite over hypotenuse. So you take the length of the opposite side and divide it by the length of the hypotenuse. Cosine, you take the adjacent side, divide that by the hypotenuse. And tangent is opposite over adjacent. We have 3 more trig functions. The cosecant, written CSC, that's 1 over the sine. So just take your sine and take the reciprocal of it. So I'm going to do hypotenuse over opposite to get cosecant. Secant is the reciprocal of the cosine. So do hypotenuse over adjacent. Cotangent is the reciprocal of the tangent. So do adjacent over opposite. So that's our 6 basic trig functions that we will be using today. The other idea we need to remember is Pythagorean's theorem, which says that a squared plus b squared equals c squared. A and b are the legs, and c is your hypotenuse. So when you use Pythagorean theorem, just plug in the numbers that you know and solve for the one that's left. And that's going to allow us to do problems like this one, where all they've given us is 2 of the sides. Here's theta, and then the 9 touches the 90 and the theta, so the 9 is the adjacent side. The 13 is opposite the right angle, that's the hypotenuse. And then what's left is opposite. And as you can see, it's on the opposite side of the triangle from the theta. Now to compute all 6 of our trig functions, we have to know all 3 sides. So I'm going to use Pythagorean theorem to calculate the opposite side. So for the purposes of doing Pythagorean theorem, I'm going to call the opposite side A. The adjacent side is B, and the hypotenuse is always going to be C. So I'm going to have A squared plus B squared equals C squared. Just plug in what I know. A squared plus 9 squared equals 13 squared. And then when I solve for A squared, I get A squared equals 88. And then I need to take the square root to get A. So A equals square root of 88. But don't leave it like that. There is a perfect square under the radical. This is the square root of 4 times 22. So I can pull that 4 out. And when I pull it out, I have to square root it. So that gives me 2, which is the square root of 4, times the square root of 22. That 22 is not a perfect square. I can't pull it out, so it's stuck under the radical. So now I know that my opposite side is 2 square root of 22. So now I'm ready to do sine, cosine, and tangent, and then their reciprocals to get cosecant, secant, and cotangent. Sine is opposite over hypotenuse, so 2 root 22 over 13. Cosine is adjacent over hypotenuse, or 9 over 13. Tangent is opposite over adjacent, or 2 square root of 22 divided by 9. Now let's get our other three, the cosecant, secant, and cotangent. And those three are known as the reciprocal functions, because you just take the reciprocal. So cosecant is going to be 13 over 2 square root of 22, because I just took the sign and flipped it over. Don't leave it like this. You have to rationalize. So I'm going to get 13 square root of 22 over 44. Secant, just do 13 over 9. Just flip that over, and that's good. Cotangent, flip over the tangent. So 9 over 2 square root of 22. Don't leave this, rationalize. So root 22 over root 22 gives me 9 root 22 over 44. And that one is done. All 6 trig functions, lickety-split. The next thing we're going to do is the same thing, but this time we're going to use special right triangles. So our first one over here is a 45, 45, 90, and I already have the lengths filled in, 1, 1, and root 2. You can do a Pythagorean theorem to check those if you want. And then this other one is a 30, 60, 90. And again, I filled in those side lengths. The hypotenuse is 2, 1, and square root of 3. And we have a chart that I put here for filling in the sine, cosine, and tangent of these special angles from our special right triangles. And it is well worth memorizing this. Will save you a lot of time. So sine of 30. So I'm going to go to my 30, 60, 90 triangle. My angle's up here. So adjacent is the root 3. Hypotenuse is the 2. And opposite is the 1. Sine of 30, opposite over hypotenuse, I get 1 over 2. Cosine of 30, adjacent over hypotenuse, so I get square root of 3 over 2. Tangent of 30, opposite over adjacent, so I get 1 over square root of 3. Rationalize, don't leave this, so I get square root of 3 over 3. Sine of 45, now I'm going to my 45, 45, 90 triangle. And notice both angles are 45 and both legs are 1. So it doesn't really matter which 45 angle you choose. I'm just going to choose this one. So this one is opposite. Down here I have adjacent. And here's my hypotenuse. Sine of 45, opposite over hypotenuse. So I get 1 over square root of 2. Rationalize this. Cosine of 45, I'm going to do adjacent over hypotenuse, which is also 1 over square root of 2. And I rationalize that. And I still get root 2 over 2. And then tangent of 45, opposite over adjacent, that's 1 over 1. Don't leave it like that. Reduce that to 1. Now sine of 60, cosine of 60, and tangent of 60, I'm going to go back to my 30, 60, 90 triangle. But this time, my angle is the 60-degree angle at C. So 2 is still the hypotenuse, but now the root 3 is opposite, and the 1 is adjacent. So check out what happens. Sine 60, I'm going to do opposite over hypotenuse, I get square root of 3 over 2. Cosine of 60, adjacent over hypotenuse, is 1 over 2. Tangent of 60, opposite over adjacent, square root of 3 over 1, which is square root of 3. Now compare to our sine of 60, sorry, our sine of 30 and our cosine of 30. Do you notice sine of 30 is the same thing as the cosine of 60? Check this out. They're the same. Also take a look at sine of 60 and cosine of 30. They're the same. It's because these angles are complementary, and we ended up just reversing adjacent and hypotenuse. So you get the opposites. The last thing we're going to do is evaluate a trig function on the calculator, and it's a little bit more complicated than you would expect. And the reason is we're going to evaluate the cosine of 5 degrees, 40 minutes, and 12 seconds. And make sure your calculator is in degree mode. You should see a little DEG on your screen. Or if you punch in tangent of 45, you should get 1. That's how you're going to test your calculator to make sure it's in the correct mode. All right, so I need to do some conversions. There are 40 minutes in my problem, and there are 60 minutes in 1 degree. So 60 minutes is 1 degree. And then I also have seconds. I've got 12 seconds there. And there are 60 seconds in 1 minute. And I still have 60 minutes in 1 degree. So what I'm going to do is I'm going to convert the minutes and the seconds into degrees. So I have 40 minutes. Multiply that by the conversion factor. I want to get degrees. So I'm going to put degrees in the numerator, and I'm going to put minutes in the denominator. And then my minutes are going to cancel out, and I'm going to be left with degrees. So 40 seconds, if I punch that into my calculator, I'm going to do 40 times 1 over 60, or just divide by 60. And I get 0.666, and this is going to be repeating. Now I'm going to play the same game with my 12 seconds. I have 12 seconds. Now I need to get all the way to degrees. So the first thing I'm going to do is convert from seconds to minutes. And I know that I have 60 seconds in 1 minute. And then I'm going to convert from minutes to degrees. And I know I have 60 minutes in 1 degree. So I'm just stringing these conversion factors together, which is going to give me basically a 12 divided by 3600. And I get a 0.0033, and that repeats. So I'm just going to add these onto my degrees. So now my 5 degrees, 40 minutes, 12 seconds is going to be 5 degrees plus my 40 seconds over 60, which is what I get from my first conversion, plus my 12 over 3600. And this is all your book shows you, is this piece. But what I've shown you is the reason why you put these conversion factors in the way that we do. And go ahead and add all of these together on your calculator. So I do 5 plus, I'm going to do a 40 over 60, plus a 12 over 3600. And I want to show you the way that looks in my calculator. I'm not sure that I can, but what I did in my calculator is I punched in the 5 and I put these in parentheses. Make sure you use the parentheses, otherwise your calculator is going to mess it up. And when you do that, I get 5.67 degrees. And it gives it to me like that exactly, just 5.67. And so now all I got to do is punch my cosine button, put in 5.67, and that will give me my answer. So cosine 5.67, I get on my calculator, it says 0.995107473. That's what it displayed. Round this off to 4 decimal places. So 0.9951 is my answer. And that's it for today's video. Thank you for watching and have a great day.